Language. Go ahead, admit it. Come on. None of you. Good. How many of you have actually played with F# before? My people. All right. How many of you have actually played with type providers before? The Microsoft guy almost doesn't count, though. You know, we kind of assume that. We've got one more over there. So good. People who have played with the language and don't know this really awesome thing that's baked into it. That's the best case scenario of everything here. You have to give me a bit of an allowance here. I got into town really sick, so if I suck down a little extra water, bear with me. If I have to cough into my sleeves, bear with me. So who am I anyways? Let's talk about this. My name's Chris Gardner. I am a developer at Caravolution down in Ann Arbor, which is why I happen to be in town this week. I'm also the chairman of the DevSpace Technical Conference down in Huntsville, Alabama. We just had our conference last month, but if you're interested in any information about our conference that'll be next year in mid-October, talk to me. I'd be more than happy to talk to you about that. I'm also one of the MCT regional leads for the Eastern region. So if you have any questions about the Microsoft Certified Professional or Microsoft Certified Trainer program, please talk to me. I'm more than happy to talk about that stuff. But enough about me, right? We want to talk about this guy. Not really. But who is that guy? Anybody know? Who? No. Arthur C. Clarke. Anybody know why I bring up Arthur C. Clarke? One of the most overused quotes in geek terminology. Clarke's third law. Any sufficiently advanced technology is indistinguishable from magic. I bring that up because I've been programming for 32 years now. I've been a professional developer for 20 years now. Never before have I played with something baked into the language that I looked at how easy it was and that it just worked and said, this is Smurfing magic. It really is. So much so, this is not because this is a brand new talk and to the point where I don't even have a witty subtitle or couldn't give you a good abstract. But it's so easy, I'm going to live code the entire demo. I know. You're looking at me like, good, let's get the tomatoes out. We're going to see somebody crash and burn, but I think we can pull this out. None of you never done massively pair programming, where you're programming and an entire audience is sitting there looking at it? Yeah, work with me here, people. We do have some shortcuts, don't worry. So what is a type provider? So if you go down to Microsoft, no pun intended for the fact that we're in Microsoft, an F# type provider is a component that provides types, properties, and methods for use in your program. There's a nice URL that you can go look at later, which this quote is pulled for, that also has examples for some of the type providers we're looking when you need more details later or whatnot. But we need a real definition you can sink your teeth into, right? So how about this one? It's a magic thing that saves you time from writing hundreds of lines of boilerplate code and updates itself when the data source changes. How awesome is that? And you get to, and this happens for nothing. So why use them? Like everything in F#, they're 100% statically typed. So the compiler knows if you're doing something wrong and won't let you do it at compile time. They update with the data source, usually. There's a couple caveats to that we'll get into while we're going into this, but usually they update with the data source. They update at compile time, so again, they won't let you do anything wrong. And they're baked into the language, so you're basically getting them for free. And of course, I say baked into the language, and you're going to see me grab 3 NuGet packages. But they're NuGet packages from the F# language people. I forgot the actual name of the group. I'm sick. Give me some break. So, why would we not want to use these, right? Right? Come on, people. Give me something. Right. Yeah! I'm 600 miles away. I need some excitement. Right. All right, let's do this. Good. All right. So, got to fix some screen things. Are we duplicated? We're duplicated. So to prove there's nothing up my sleeve, I'm opening a brand new instance of Visual Studio, right? And we're going to come here and we're going to say File, New Project, right? Nothing strange here. Here you go over to F# and say I need a console application. We're just going to use the default console application 1. No reason to change it. And we have standard F#. Some of you have seen this before. Nothing strange going on here. We're going to create a new file just because I want to keep my type provider separate just so that we can see what we're looking at here. So come over here, Control Shift A. We need a code file, source file. So what do you think the easiest one we can tackle is? And I'll give you a hint. If you can read the squinty lines up here, it's the one type provider we're going to grab that is already baked into this project. There's an app config file up there, right? Well, how annoying is it to like grab the default providers they use and do all that stuff on it? So we're going to call this guy settings. All right, so we have a new module called settings. So the first thing I need to do is we do have to go grab a NuGet package. Where are you? Manage NuGet packages. This is where I hope I'm still on the internet. We'll grab f#.configuration. From the F# foundation, nothing strange going on here. And then we're going to come in here and we're going to create a new type. And we're going to call it settings because I'm lazy, right? We're going to say app settings to our app config. And it is smart enough to know that when we actually compile this thing and it's going to be console application.exe.config to grab it from there. So we don't have to worry about that. There is a thing in there that if you need to give it a different file name at runtime, there is a way to do that. And of course, we need to use something, right? So we're going to open that f#.configuration. And now we're good to go. So now we're actively, if I compile this thing, we're reading from our app config file. But you're like, yeah, there's nothing in that guy, right? You just started this project. So I need to prove something to you, don't I? So let's open that. Well, first of all, hello, F#. We got to get this guy above the program file. Let's open our app config file. So there's nothing in it. We can fix that. And here's where the fun part happens. You didn't think this was going to be interactive. Oh, this is interactive. Because I got to prove I'm not faking things. So let's open an app settings. Let's add a key. What key should we call it? Anybody? No, because I'm not going to type that. Pi, sure, why not?
I said pi, that's okay too.
Pi, all right, well, we'll call it pi. So I suppose you want to give it a value of something like, well,
I was thinking like
3.2 is close enough, right? We'll just round it. So now we might need to create ourselves a key called is pi correct, so that we can give it a value of no. All right, give me something else. What? E? I know what it is. I got a degree in math. 2.7 is close enough. We're not going to ask if that one's correct. Let's get two more things in here just to prove I'm not doing anything strange. You'll see why in a second. Another name. Don't care what.
Is Chris Gardner doing anything strange?
That would be a bull. I don't want to do another bull. Why? Wat. Wat.
Okay.
Give me a string value.
42.
All right, give me an integer value. Good enough. All right. Let's do it. Let's do one more that actually is a string.
42.
Right. Well, okay. Now, I don't think it'll take a configuration a key that's. Well, let's see. I never tried it. What? Let's see if it'll work. All right. So now we have this nice configuration file. So now if we run this thing, no, not run it. Compile it. Compile it. It's now gone to our configuration file, and it's sucked out all those beautiful values. You believe me? No. Do I have to prove it to you? All right. So we're going to come here, and we need to actually open that module. Let's take this, and let's start. What do we start with? Float. Right. Settings dot. Ooh, it did take 42. Settings.py. Okay, so that was correct. The beauty of F sharp, is that an integer? No. Notice it immediately told me, hey, no, you gave me a double. I can't take an integer. So put that back to a float. Not a, yeah, float. So what about the rest of these guys? Let's do some copy and pasting here. So what else did we have? Well, then we had a Boolean. Where we asked, is pi correct? So now that one's fine. Then we had another float where we did e. And then we had a integer named what. And these are probably because of case sensitivity. Yeah. And then we had a string called 42.
Hey, Chris, 2 questions.
Yep.
1, do you take questions during your talk?
Sure.
And 2, did it auto-capitalize E? Because you didn't have it as a capital config file.
I believe it may have.
Okay.
And it's really not liking 42 even though it sees it. Try surrounding it with double backticks. What? Oh, double backticks. See, I understand what you say sometimes. It just, my brain goes, yeah, I used to. There we go. So now it's happy with it. Now we want to be able to tell this actually happened, so let's call it a system dot, not configuration, console dot read key, right? And this being F sharp, we have to tell it, I don't care what the value was. So now if we run that guy, completely type safe, we just pulled everything out of that config file. Look like the values we put in there? Everybody happy? You think that was just a one-time thing? Wait, we got a picture. All right, he's got the picture. Good. And yes, we can go back in here. And, because I really can't do this myself, so we're going to make this recompile that, fix that value, because I really can't sleep at night if we leave pi incorrect. So now it's live pulling from the data source. Is that cool or what? God, you guys are killing me.
Impress us.
Impress you? I thought I just did. Oh.
You're getting there.
We're getting there.
Oh, we're getting there.
All right, well, what would be more impressive than an app config?
I don't know. You're going to talk.
Database, that's the grand finale. So what would be between a SQL database and an app config? Well, sort of. We're going to go for a JSON data source. Yeah, pretty much. All right, so we need a new file. Oops. Add new item. It's source file. Let's call this one JSON. Let's move it to the correct place. All right. So this one should be fairly easy. We're going to open something else. This time we've already got it. Truly baked in. We're going to open F sharp data. So now we can create a new type. We're going to call him JSON data. And it's going to be equal to a JSON provider.
So I got a question.
All right.
So the language comes built in with JSON but not actively?
It actually does, depending on how much of the F sharp specification you have it download. I have mine that set on really, really minimal and just grab them as necessary. So that's why the configuration went in there.
I just thought that was high.
Oh, don't worry. I have to pull the SQL one down here in a minute, too. Yeah. And I think I actually, pulling the configuration one grabs data with it, actually, I think. Because data is the default type provider library. So, but we need some JSON, right? So let's create some JSON. So we have a JSON object. Fairly boring one, but we have one, right? Probably should put something in. Give me a key. You really like that one, don't you? All right, give me a value for it. What?
I was just going to keep making references to wax.
Yeah, I figured.
Kind of like starting to go down.
Do I indeed look like Gary Bernhardt?
Yes.
Sweet! I have a new claim to fame.
But you're sexy.
Buy that man a beer later, even though he's the one buying all your beers. We got to do something circular here, considering he keeps saying why. All right. How about puppies? Good enough? All right. Give me another key. No. Watt with 2 T's. So how many watts does my power supply do? 1.21 gigahertz? Yeah, gigawatts. So maybe we need to call this gigawatts. So, you have 1.21 gigawatts. Give me one more good one. One more good one. Oh, one more good one. You just know I have to type all these out later. That's what we're doing here. All right, let's give me a value for it. Any value you want. 100? 100. Andre. What? Yeah, it'll just be an embedded object. Let's get the simple one first. We'll start building on it. Fine, we'll call it Andre. Andre, you're now famous. All right. So, and my build failed. Why did my build fail? Because JSON provider is not. What was it actually called? Oh, because I didn't add the reference to it. All right, let's go to the cheat sheet. Open F# data, it's JSON provider. Oh, I hate it when things like this happen. Yeah, I know, the natives are getting restless now. Did I miss? No, that's wrong. Type JSON provider is not. It should be. Alright, we're going to do this. Drop back 10 punt. Manage NuGet packages. Browse. For F# data. Give me F# data. Now it's happy. All right, so now we have JSON. Now, because of the way we're going to build on this, we're going to do something slightly different than we did last time. And I'm actually going to create an F# function to do the display, because as we start adding to it and making this an array and adding more data to it, it'll be a lot quicker in the long run. So, we're going to let print JSON, pring JSON. Let's just call that JSON data equal. Now we are going to do this real quick because we're not going to use this guy right away, so we will type definition him. Oops, nope. JSON data dot root. So we're going to say that we need that root from that JSON data we just created. That's what we're going to be passing in here. Now we can do a print fn. What do we have? %s. Helps if I have a T, right? You guys are supposed to be my pairs. Don't make me pull the Mac out. This demo works there. Thanks to today. How many of you played around with Visual Studio for Mac today? It is, but it actually works remarkably well with the Visual Studio skin on top of it. I was mostly impressed that I said go to Windows hotkeys, and it made me do a Alt F4 instead of a Command Q to exit. Thought that was a nice touch. It really was. All right. So there's our what, and yes, it forced the capitalization again. I'm over it. Are you over it?
Did it show you the telesense for what's in the JSON?
Yes.
Oh, that's cool.
So, and then we had, looks like a float for our, oops, gigawatt. Notice I just did a completion on that. And then we had another string for one more good one. So now we can print that guy, right? Everything's going to be happy. So let's go back to our program. We need to open JSON, our new module. We don't necessarily care about this stuff. So where are we going to get this stuff from, right? Well, for our main development purposes right now, we can say, let's just call it our data equal the JSON data, and we're just going to call this function down here called getSample. And that's going to actually pull that sample data we had so we can use it for testing purposes. So now we have all that data we had. I can take that, I can go straight into our print JSON method. It's there, I promise. And pass in data. Oh, because it's not compiled yet. And now it's happy. So we're gonna suck that sample data out. But that itself is not impressive, right? But to help with the impressive factor before we get to the impressive factor, we need to make things impressive. Am I being redundant enough yet? All right, good. Just making sure. All right.
So you just about recursion?
Yes. I'm recursively teaching you about recursion. All right. So this is nice and all, right? But what happens if you get more than one thing back? So now I have an array of objects. If we build this, we annoyed the compiler gods. See, down here it says build failed. So what happened? GetSample's not happy. Why is GetSample not happy? I know most of you can't read that, but what it actually says is GetSample is not defined. Why do you think GetSample is not defined?
Did you define it?
No.
That might be why.
It's baked into the type provider. It's GetSamples because we now have an array. But now what happened? Yeah, now we got to iterate through our data because we have an array. Well, who in F# likes arrays? They're no fun. Oops, we still need you over there. So what we're actually going to do is we're going to do a array.toList of our data. And we're going to pass that into a function called print JSON array. And now that's going to complain legitimately why? Because we don't have one of those. And now if I come back over here, let recursive print JSON array, we'll just call it A since it's an array. All right. Match A with empty list, return with head tail, if I can spell tail right. And then we're going to print the JSON with the head. Now it's happy. We're going to print a new line, and then we're going to print the rest of the JSON array with the tail. Right? Simple recursive function just to iterate through our list. Nice F# way. Don't worry, I'll do a for loop one later. So we build that, and now we've got the same result. So how can I prove this is even cooler? Because what really happens when you're playing around with JSON? How about, oops, half the data doesn't exist? All right, happens to the best of us. Right? Because, oh, yeah. So now we're going to do this. And do you think this will work? Yes? You have way too much faith. Because it shouldn't work. Why shouldn't it work? Because I have nullable types now. And what does F# not like? Nulls, right? Nulls are the devil. Nulls are the things that keep the F# compiler up at night. So if we go down here, our two things that are now nullable, it said, wait, we can't do that. I don't know what's going on here. So how do you think we fix that? What do you think it did to it in the background? It made it an option type. Good. So it actually, transparently, we come here and say, match our JSON data dot gigawatt with none. Oops. And we'll give it no gigawatts or some G, and we can return G. And then we'll pass in that. And now, well, okay, that's not, anybody know why that's not happy? Because actually when it pulls off that JSON is a decimal. And so it's having a type conversion war now. Easiest way to get around that is I'm going to cheat. And just convert it. Oh, what's it actually called? Just, yeah, thank you. I knew I was forgetting something silly. So now they're at the same time. It was having a type war. So now we got the same thing for the string. Let's borrow some code because you're not here trying to watch me type all night, even though, guess what? You're going to end up watching me type all night. Exact same idea, but now we're going to match on one good one. Nope. Don't even have to bother changing the variable name because it's hiding in a match statement. Now everything's happy. And we're pulling off from our null data. We're getting more cool, right? But now you're saying, how do we use these things? All right. If it did that automatically, which part automatically? Oh, if it's null. When we get to the SQL data, it actually uses system nullables, and it does do that.
I was just thinking like how JSON can work or JSON.net works with C#. How it just makes it just use the default for.
Patience, Grasshopper. So let's come here. Let's add a new project. Web application, web API. Let's create a web API project real quick, shall we? Welcome to ASP.NET 5. We're going to come here. Let's go to this controller. Let's go to the values controller real quick. Don't worry, I am not going to type all this in. All right, first thing second. How to use Newtonsoft. So now all of our JOps works. What was the name of all our stuff? We had a watt, right? And then we had gigawatt, and we had One more good one. And those were what? A string and a double and a string, and the double was nullable, right? So far so good? Do we have a bunch of strings? All those are okay. These were all double, so give me a double. 2. 2.0. All right. Give me another double. 87. It's a double. And since you want 4.0, 4.0. They're boring doubles, but they're doubles, right? We need a couple more strings. Somebody give me a string. Thanksgiving. What else do we have here? Pumpkin pie. Why is that? Did I not change the data type? Oh, yeah, because here's string. Now it's happy. And since I don't want to ask people for more things, we'll have 2 nulls right there. So now we have this web API running. We got to do one strange thing real quick. Let's go to our properties, because what do I need? One, I don't want it to launch in an endpoint, but I do need a copy of where it's going to launch it. Make sense? So now back in our program, instead of saying get samples, I just say, hey, let's load let's just load that endpoint. One more thing I have to do. Well, let's just do it this way. Start up a new version of that web API so that we can get it running. Now we can start up our... Yes, you can build it. And now we just pulled live off the API site. So that was cool. We getting better? You guys want me to go all the way, don't you? You're going to make me do SQL data, aren't you? Because you want to see me live write a SQL database, don't you? I don't get paid enough for this. All right. Let's do this. Stop our web application. Okay, we had our fun with you. All right. So now comes the trickier one. We got to pull another NuGet package. I'm going to do that up front. We need this F# data.type providers guy. And we also have to manually pull 2 other things. We need to include system data and system data link. Anybody have a good clue why we have to pull system data link? Because we're using a link to SQL in the background. That's what the type provider is using in the background. Yes, this is for SQL. So, the first thing we need, first of all, we're going to come right here. I got a whole bunch of SQL there, so you don't have to see me write a whole bunch of SQL. We're going to tweak the SQL as we go along to prove that I'm not baking names or anything. But do you really want to see me type out that much SQL? Go ahead and say no. Somebody don't buy that man a beer. All right, control new. What should we call our database? All right, thank you. Gang. Now we're going to use it. So now we have a database called Gang, and we're in it. And now it's going to come a whole bunch of SQL that you don't want to watch me type, but we're going to go through it as we do each part of it. So originally we need some sort of top-level table. We can rename this top table whatever we want. Just if you want me to prove that I'm not baking anything here, what would you like me to rename the table to? Just remember, you have to remember what we rename it because I got to change it in other places as we go down.
Purple.
Purple? We'll name it purple. All right. We do have to have an ID that is a primary key. That is a requirement of link to SQL. So we can change the name of our ID from something other than ID, but I cannot keep it from being the primary key. Fair enough? Do we want to rename it ID? Please don't make me rename the ID. I'll do it.
I think you should call it ID.
All right, we should call it ID. Now, this guy just called data. He's kind of boring. We want to rename him something else? Fred? All right. We have Fred. Do we want to add any more columns? We can add as many as we want. Doesn't bother me any.
Ryan.
We want Ryan? All right. What is Ryan?
Currency.
He's a currency? Actually, aren't they called? I was about to say it's called money. Actually, is
Make it nullable.
is it nullable? Yeah, I was about to say money sounds pretty nullable. All right. What else do we have? Anything else? We're good with that for now. All right.
Yes, we have Jeff.
We have Jeff. All right. Why do we need Jeff? Well, we'll have Jeff, but why do we need Jeff?
Ryan, he's giving you a look that says he doesn't want me to be alone up there.
Okay.
You can make Jeff an image.
The only reason I'm going to say no to that is because I'm not quite sure how the data type's going to come back off the top of my head, and so I don't want to try to figure it out live in front of you guys. It's probably going to come down as a byte array, but I'm not sure. So let's do something that's not quite that horrible.
I was going to say a tiny int.
Tiny int. Yeah, we can do that. We'll do a tiny int. And if Ryan doesn't have to be here, Jeff doesn't have to be here either. Let's just be fair about this. All right. So let's run that guy. So now we have a table. Yay, table, right? Now we need to add some data to it. So what do we call our table? Purple. All right. And then we renamed that. I don't remember what we renamed the columns. It's a good thing it's up here. I'll fix that in a second. Fred, Ryan, and Jeff. All right. All right, so Fred was a varchar. Just to prove there's nothing up my sleeve. There's Fred 1, 2, and 3. Ryan was, let's see here, a currency, correct? How about for the first one, it'll be about 350. We can do about 250 for the other one, for the next one. And you can have null right there. Because we got to prove that the nulls work, right? And then what was Jeff? Oops. Tiny int? Oh, yeah. Okay. So, 1, null, and null. So now we have some data, right? Just something to play around with. So we got 3 rows of data. Nice starting point for everything. So let's go back to our F#. Of course, we got to create a new file for this because it's going to get kind of ugly kind of fast. Not because just when we start adding other tables and stuff. Not that the code itself is complex. All right. Add source file. We'll call this one SQL. All right. We need to open F# dot data dot type providers. Now, if we were going to open a SQL database normally, how would we do it? SQL connection. So what we're going to do is extremely close to that. So if we have a SQL connection, what are we trying to get? Data, right? So what if we just say, all right, well, we need a new type, which is our DB schema. Could be named anything, but I've just gotten used to typing that for all this. All right, and we're going to open a SQL data connection. Now, the main parameter we have to give it is what? Connection string. And this does have to be a hard-coded string-ish. Has to be a compile time constant.
Or you go type provider exception and use one type provider and
No, because it has to be a compile time constant. Yes, because at compile time, it's actually going to update all its references. So you can do all sorts of things where there's, pound defines and stuff, but it does have to be a compile time constant. Just because I have the brain of a fish, here is a nicely already mostly written connection string for me. And all we need to do is say that we actually named it gang. Now, to prove a point, here in a second, this thing should... We're gonna do this first. There we go. So it actually went through and it tried to suck the data. Notice everything resolved. This is currently a live connection to the database.
So, as you're coding, it keeps a connection open?
Not yet, but it's about to. What is it? Force update? Now it is. So as we start going through this demo, and we start changing the database, and I do a rebuild on the F#, it's actually going to go and live update our data source. So right now we're going to build this, and it's going to suck all that data down. So now it knows about what we were just doing. It knows about all that goofiness with Jeff and Ryan and Fred and Jeff's tiny ant. But again, this is a live connection. If I change that thing, we give it a second, it should say here in a second, I can't find that catalog. Do I have to rebuild it first? Got to rebuild it first. So now it came through, and the error we're getting is that I couldn't find that database. So that was indeed a live connection. All right, so now we have this beautiful DB schema. And we're live connected to the database. So what should we do with it? Well, first we probably want to, let print top table, this is going to be a row, equal print fn. So what, we had a int first, and then to make it easy, we're going to do a %s on top of that. So we have this row and it had an ID. It has no idea what the types are. Do you know why? Because we have not done anything to let it believe that row is any sort of a reasonable type. So do you think we should see if the type inference engine can pick it up later, or do you want to see all the nice IntelliSense? You want to see all right, we'll do it. So all the data types do indeed exist. So how about if we go in here and we say that this has to be a DB schema dot service types dot purple, since that was the name of our table. Now it knew what an ID was. Of course, it still wants me to give it a... Oh, see, now we got to remember which one. Fred was the string, right? So now we got our string. No, what were the data types on it? Currency. I believe that one should be okay with a float. Let's see. And that was Ryan, if I recall correctly. So it actually saw it as a decimal, and I can't remember what the format specifier for a decimal is, so we're just going to cheat in real quick. Is it M? Nope, doesn't know what an M is. No, C is a car. It's not F. Yeah, we'll go back. We'll go back to the float and just do what I was going to do, which was. Oh, I see what you're saying. Just convert it to a string. Right? Now we're happy. Tiny int should be happy with an int. Oh no, because the tiny int is a byte. That's what it's saying. We bit off more than we could chew. Yeah, I went there. Oh, so did I go there. All right. It's all right because we can fix this. We'll just make it short. I'm in a 16.
I was gonna say, I think 26, that's interesting.
That would have been interesting, though.
What's in the 26?
And
Is it like,
where'd my... What's the point of having a touchscreen tonight?
maybe because you ended up.
No, it's just because I have to say this whole thing is the parameter. So now we have one of those. But of course, how many rows do we put in? We put in 3, right? So let's go ahead and... say this guy was called purple. So we need to actually first print a purple row. And now we're just going to print purple. Right, and this is going to be rows. Where's my... Let's cheat. You ready to cheat? All right. Yeah, I know it. All right. So now we're happy. So now we can go back to our main program. So how do you think we're going to get into this guy? Anybody know why settings is crying? Because we didn't put SQL above program. All right, we don't care about this JSON stuff anymore. So, let's let ourselves have some SQL data equal to our DB schema dot. This time we're going to call a function. It's not compiled yet. I believe it's get data context. I know data is not defined. So, you think we can just now... So now we have the SQL data, and it actually now has a live capture of the snapshot of our data. Do you believe me when I say that? Go ahead and say no, because I'm totally lying. Because do you think it's really going to be this nifty tool, and if you have big data and millions of rows of data, when you run the program, go and grab every single row and hold it internally in memory? Good, because it doesn't. It's actually all lazy evaluated. These are just contains the reference, the pointers to them, and you can turn them into iQueryables. You can limit them. Not until you actually start pulling data is it going to create that query and actually pull it at that time. But with our SQL data, we now can say SQL data, and look, now we have this nice guy called purple. What do you think purple is? If you had to guess a data type, go ahead and think in C# terms. What do you think it would be? Collection's close. Can you be a little less specific? IEnumerable. It is indeed an IEnumerable. What is IEnumerable in F#ES? It's a sequence. Very good. So now instead of being an array to list, we need to be a sequence to list. So let's pass that in. And now we don't want to print our JSON array. We want to print purple. Think we have a life pull off for data? Think we're going to get all that wonderful junk we created? I hope so. I like it when stuff works. Well, how about that? So the empty lines are because it actually were system nullable, and in the background it converted that to an empty string for us. And then the zeros were the default values for null. But that's us pulling live off our database table. So that is already should be pretty cool, but we got to make this stuff even more cool, right? Way more cool. Because what happens when we want to symbolically call information? Let's go back to our database. Right? We need some sort of lookup table. So what do we want to call our lookup table? Thank you. Hey, does anybody really want to change the name of it, or can we just prove that we're getting live data now and I can not have to change as many variable names? We'll be the gang lookup table. That'll make a user change. Do we want to call this something other than value? Of course, we do still need the ID. Good enough?
Let's call this one Dustin. Yeah.
All right, yeah.
You can make your data cool.
I'm leaving this one a var car. All right, so this was the... Oh, actually, it would help first if we actually created our table, right? I'm not that worried about it. We created a primary key name after the primary key. I'm good enough with that part. Because I'm not going to be modifying these later when we're going on. So now in a gang lookup table, poor Dustin gets to have 3 personalities. Not F7. So now we have 3 rows in our lookup table. Now comes the really fun SQL part. This is one of those parts where I warned you about not making me change too many things. All right. So top table, that was actually purple, right? So we actually need to add gang lookup table ID. And then we need to go into purple. Set a value. Right now, just to make it quick, I'm setting them all to the first one, just so that we can proceed with the rest of the SQL. All right, then we need to alter. See if I can get both these at once. Purple. We need to alter gang lookup table ID to make it nullable now that it has data. We need to add the foreign key constraint, which is going to be the gang lookup table ID referencing the gang lookup table. Right, and then we need to go into purple. All right, and we can pick any of those fields. We don't have to change it to 2. Do you want to do 2 or do you want to do 3? I don't care which one. Let's do 3, just to prove I'm not doing anything fishy. Which ID do we actually want to change it on? We have 1, 2, or 3. 3. What, 2? Sure, we'll do it 2. So now if we update all of those, yay, we changed the names correctly. So now we have a lookup table and our main table is referencing it, right? Good, good, good. So now we can come back here. One of the weirdisms, we're going to leave that exactly how it is for a second. One of the weirdisms when we're doing this one is that you do have to force a full rebuild to actually get it to recheck the database sometimes. Sometimes it doesn't. Sometimes you have to force a full rebuild. I'm just going to go ahead and hit Control F7 just to force it because I want the stuff to work. So now we have all those new data types. So now, for each one of these, we could come in here and for our row, we now should have a gang lookup ID. That's fast. Well, that's not impressive enough, right? Because what do we really want out of this if we're doing a lookup table? We want that value. We really want that value. So how about if I say, well, okay, what if we go into the row, and what if we're already connected to the gang lookup table, and from there I can just pull Dustin. Oops. Let's compile that and run it. And now we're live pulling that data off the table through the lookup table. So how can we make this, what are we doing on time? How can we make this even more impressive? I'm not even going to let you change this next part because we're getting really close to beer time and I don't want to eat into your beer time. No, but we're gonna do a end-to-end. So, how about if we create some sort of other table? And we're gonna call it other table. It's got an ID, right? It's got some junk in it. So we're gonna do that, and then we're gonna throw some junk into our other table. No big deal. And then we're gonna create a join table, which joins our purple ID with our other table. And now this guy is going to, this is why I warned you about changing too many of the things, but what was top table called? Purple. And I refuse to let you change the ID field if I recall correctly, so ID should still be fine. But you all know you could, right? So now we have our join table. So now we need to come in here in our join table. We have our purple ID and we have our other table ID. And I just kind of gave one of them a bunch of them and merged them kind of together just so we had some cross-join data. So you can see that it really was an end-to-end collection. So now we have all that lovely data added to our table. Come back in here, do a full rebuild real quick. And there we go. We have all that stuff. So now, here comes the fun part. We don't necessarily want to print right away. All right? And because core's for you, I promised a for loop. We're going to go ahead and use a for loop now. I know, how very unfunctional of me. I'll cry myself to sleep tonight, I promise. For I in 0 to, well, now here comes the magic part. Row dot, we now have a join table. And it has a count. Of course, it's one index, so we need a 0 index, right? Do. All right, so now we're going to go to that join table and say, hey, go to that join table real quick, which is now you're intimately a part of. We're going to borrow one of these. And here's where the magic happens. I think I need to do it from there. All right. So, here a join table, and we need our first thing in our join table, and from there we need our other table ID. So now we're already spanning to the other table, but that's not impressive enough. So how about we go through our join table? Actually, here's the... Why didn't somebody... because we want to iterate through it, right? What? Yeah. If we could pull that one off. So, but how about through that join table, we just go straight into that other table. And from there, we could just grab... no. What did I name that thing? It was junk? Yeah. Junk. So now we're actually going through to grab the specific that was attached to that one. Going through referential integrity. So now if I compile this guy and run it, we're actually through our third lines here, coming through all that referential integrity, pulling from that end-to-end table lookup and grabbing that data all attached to it. Is that cool? Can I get some excitement now? All right, tough crowd, tough crowd. Hey, I think I've been up here an hour-ish. That's all I got, man. If you got any questions about this, I'm gonna be at the I'm gonna be at the bar with you guys for a little while later. Come up and ask me questions while we're up here. There's all the ways you can get a hold of me. Thank you all very much. And now I'll stand up here and try to do an interpretive dance until he gets back. Do we have any questions real quick while we're waiting for him? Yeah, go ahead.
So, can we use a type provider for XML copy?
Yes, there is an XML. There is a built-in XML type provider. I mean, an app config file is XML. It's not like it's a far leap from one you already saw me use. But yes, there is a full-blown one. And it will read an XSD schema file. Yes? No, but because I haven't thought of a specific use case for that.
Okay.
But units measure are just another type, and if you had something that had the correct mapping, it would do it. If you do go to MSDN, there is a complete, here's how you create your own type provider if you need to. But they pretty much tell you, unless this is something that is business critical to you and you're doing a lot, let the pros write the generic ones, just write data types for your internal stuff. Because it really is a lot of stuff that goes on in the background. Anything else? All right, I'm just going to stand over here and be like Stantler to your Waldorf for a second.